because of how things worked. We'll probably get through part 7 today. And so part 7 homework will be due on Friday. So what that leaves us with is we have part 8A and part 8C. 8A is the asteroids and 8C is like the Pluto and all that. And then we still have to finish up part 4.
1/6 is due on Friday too, right?
Yeah, 1/6 is due today. Okay. Yep. Yeah, so when 1/6 we did lecture Monday, so it's then due Wednesday. Yeah, so now we're doing 1/7. And honestly, a lot of this stuff, it's cool, it's interesting, but it's kind of stuff we've talked about, so I don't want to put you to sleep or anything like that. Here is Buzz Aldrin on the surface of the moon. We talked about the flag. Remember I said the flag actually has like a little, can you see the little support thing up there? See it kind of conspiracy. It's what? Conspiracy. Oh, right. And here's a lander here. This we saw a movie about, which by the way, I'm hoping on Friday I will, once I have the test kind of laid out a little bit, on Friday I'll give you back those sheets. Remember watch the movie and you guys come up with some great questions for a test? Mm-hmm. I'll give you back those sheets on Friday. And we might see another movie on Friday and do a similar thing. You guys come up with some test questions, so we'll see. But this is the formation of the moon. So it kind of goes A, B, C, D, E, and F. So the moon, as it turns out, looks like it's most likely ejected material from the Earth. So the big circle is the Earth. The little blob, we have an impactor here. The impactor does its bit and leaves. This right here, let me grab my pen, is the stuff that's going to kind of snowball together to become the moon. It's ejected from the Earth. And then you can see that it's been orbiting the Earth ever since. Or not. Where did it go? Okay. So we've been talking about, you guys told me the dark regions are called mare. There it is, mare. Mare is Italian. Latin, mare is Latin for seas. The light regions are the highlands. The mare are younger and the highlands are older. Craters. We kind of looked at this in lab, saw some pictures of me, or saw some pictures I took of the moon with craters. Craters kind of have the features I said the other day, like this, where they have, if this is my crater, sometimes they can have kind of stepping down, what we call terraced sides, and they have a belly button that we call a central peak. Not always, but a lot of them had belly buttons. And then they have this stuff out here that we call, remember what we call that?
How do those form?
How do the craters form? Yeah. Actually, there are no necessarily new craters being formed right now. They were formed early on, and we'll talk more about kind of how this, and I think the video talked about how early on, when the planets were forming, there was extra stuff, meteoroids, and even comet material that was floating around the solar system. And so they call it heavy bombardment. So things were hit, and then the moon was one of the targets. The Earth was hit too, but the Earth's got sort of like wind erosion and things like that that kind of made our craters so we don't see them anymore. And plate tectonics, yeah. So that stuff that's called ejected blanket. I cannot find my pen, I can't find the flipper. Okay. And footprint on the moon. I wrote up, when we were in the lab the other day and did our moon lab, regolith is kind of what that guy's stepping in, was kind of ashy material. This guy down here actually is, excuse me, you can see the nice ejected blanket from this guy. It's the crater called Tycho. Moon print. So lunar soil is just what we call regolith. So we talked about how did it get its craters? The time of heavy bombardment. Basically, there was extra stuff in the solar system that didn't become part of a planet. Okay, made those craters. So kind of from left to right, actually all of these craters and stuff. This kind of looks like the backside of the moon. The backside of the moon doesn't have the mare. They think the mare was actually formed by impacts when the moon is not ooey gooey anymore. There's not like a liquid part to the moon like there's a liquid part in the interior of the Earth. That's to do with the moon's size. But early on, it had some, if you go much beneath the crust that was solidifying, you would get molten material. So basically what happened, it was struck and it kind of thinned out the crust where it was struck, and that molten material came up and then solidified to make those mare. This is a picture of the Mare Orientale from 3.8 billion years ago. One of the things we're going to see on a slide is when we visited the moon, actually we brought back material from the moon, and it was carefully received because, you know, the whole Andromeda strain or anything like that didn't want to bring back something that would kill us all. But anyway, it was dated, and that's where we get those dates from. So the surface of the moon has that moon soil that we call regolith. And the thing about the regolith, which is kind of like that chalky, ashy looking material, the way it got regolith basically was because it was beat up over the billions of years. And it created that kind of material. Ejecta blankets, kind of that splash stuff you see coming from a crater. The lighter the color, the more recent that crater was formed. Talked about central peaks, those are the belly buttons, and kind of the terraced edges. So specifically with the mare, they're the dark regions. Some of these slides are kind of repeat slides. They're formed a long time ago. The word mare means sea. But sometimes on the moon, you'll actually kind of see these they look like little frozen rivers, and those are what we call rills. Okay. All right, highlands are the lighter colors, the lighter colored things we see from the moon, the nighttime sky even. The thing about the highlands is they basically go around the mare. So this is a crater. This might be one of our mare, our dark regions, and it's got like highlands. These are supposed to be my mountains, highlands around here. So this is young, and this is older. So these are my highlands. I'm going to hand out a map. I was going to give this to you last night, but yes, the Moon Lab did not go last night. So that means, and my backup date is in October to get the telescopes out. So there's all sorts of moon maps. There's actually, you can get 10 marks credit points if you put a moon map on your phone. So sky map with stars and moon map. They're free. The moon. What the heck? I think there's free. So I mentioned Tycho. So like if Tycho, what she gave you, if you flip it over, number 60. Yeah, crater Tycho. See how that works? So. One of on my bucket list of things is to become more familiar with the moon's features and to look at it and say, well, that's that. I don't know, I'm not very good at it. So this is some photographs from your OpenStax textbook. This looks like a full moon. What about this moon over here, guys? What do you think? Is it crescent, quarter, gibbous, new? It looks like a gibbous to me too. Do you think the way it's oriented, how many people think it's waxing, getting more bright? Me too. Yep, very good. And when we do our moon lab, we're going to kind of focus on this area right here. I've lost track of, anybody know when the full moon is? Is it Okay. 24. So, okay, so Friday, it won't be quite a full moon. That's good, because that means we'll have just a little bit of a terminator to look at. It'll be pretty darn bright Friday. So, a crater, or not a crater, a mountain on the moon. You can kind of see this one, you see the central peak, the belly button, and see kind of, this is what I was talking about, the terrace features, kind of stepping up. Sometimes you'll see craters inside craters, because that looks like a tiny crater inside of a big crater. So you kind of get a sense for which came first, the big crater and then the little crater. This is kind of looking at one of the seas, the Mare. Another picture of the Mare. In the band that I play in, the orchestra I play in, we've got one of our percussion guys' name is Dave Scott. So I think this is kind of, here he is, this little dune buggy. And actually, I'm going to play this for you. I found it. It's Apollo 18. So like the slide says, 13 was the first, 11 was the first one to manned mission to successfully set down. If you get a chance to go to the, in Chicago, it's the Adler Planetarium, or any sort of planetarium where they talk about the missions to the moon. It's just amazing. The scientists, the men, mostly men, put their lives on the line. In the case of the space shuttles, it was men and women, but they didn't all come home. So 11 we sat down, 1969. There were, did I say, how many missions? Total 6. 6 successful manned missions to the moon. 17 was the last one. So 17 was the last one. So here's a kind of get a little sense of the scale. So at the observatory, you're never going to see a telescope. You will never be able to see the flag from our point of view. But those are big features. I said we were careful with the rocks that were brought back. Here you go. Actually, anything brought back from space, handle it as if it's contagious. So when they brought back rocks, they kind of classified them in 3 different types. So these are moon rocks. This Mare basalt is similar to like our volcanic rock. Anorthosite is similar to our mountains rocks. Impact breccias are similar to some of our metamorphic rock, where basically it was hit, just like the word impact suggests, and underwent transformation. This is a close-up of kind of the basaltic sort of rock. So they're still learning things about the moon, and I'm not sure if OpenStax, that your textbook this semester emphasizes this, but as they were orbiting the moon, they found that there were places in the moon that were kind of reaching out and had an extra tug. I know the moon did not reach out, but it had an extra tug on things that were orbiting. And actually, it just looks like the moon is not the same throughout. It's got kind of a heavy spot to it. There's water on the moon. A lot of it is tied up in its solid state near the pole regions. But just like the water on the moon, just like the water on the Earth, they think the water on the moon was deposited early on by comets hitting it. So far, there's no evidence of life on the moon. And that gets us to slides. So that's as far as I wanted to get today. Let's go ahead, we got time. Let's go ahead and we won't get through part 4, but let's look one more time and pick up part 4, see what that looks like, okay? So this homework, part 7 homework.
Because I can't, for some reason, I don't find it on Canvas.
You can't find it?
Or I don't know. What did you say?
Part 7.
On Windows, do you know, assignments will have 1 through one dash and then all the way to like one.
I went to like modules or something.
Yeah, you go to modules and then you go down and it should say like unit post, unit one or something like that. And you click on it and then it'll give you a whole list of.
Okay. Cause
Yeah, that all
Yeah,
sounds
click on
right.
Unit one to post or something like that.
Yeah.
You click on it.
okay, thank you.
All right.
So chapter 9, this 1-7 is gonna be due Friday, correct?
Yeah.
Cause today's Monday.
Yeah, part 7, yeah. Yep. So this one, way back here-ish, I think was where we left off. Way back in part 4. And this was where we said like the whole A, B, and C. The A is where a guy shoots a gun with us going kind of a slower speed. B is even faster, and C is even faster. So eventually, the guy with the gun, which is weird, but he or she shoots it fast enough that even though it falls to the earth, as it falls, it kind of misses the earth. So it's keeping falling, but it's missing the earth based upon how fast it went in the first place.
Soon enough, it ends up shooting him in the back.
That's my gosh. You're totally right. That's what that looks like. Oh my goodness. So we talked earlier about Newton's 3 laws of motion. And remember, they match up with Kepler's laws as the planets orbit the sun. So Newton was more general, and those kind of circles are all follow Newton's laws as those objects orbit the sun. So we have the planets, we have comets, we have asteroids, they all follow Newton's laws. This one kind of should freak you out a little bit. So this is your precious planet. Each one of those dots is potentially space junk. Yeah. So it's a busy place in outer space these days. So you figure maybe 30, 40 years ago, people launched a satellite, a communication satellite. Well, that doesn't last forever. And when it stops working, what do? They usually just leave it up there and put another one out in orbit. So you can kind of see the accumulation. I think it's called DARPA. There's actually this has been several years ago, but people are like, hey, why don't we make a gizmo where we can go up there and kind of capture things? You know what I'm saying? So it's a thought. That's not all space junk. But now I feel like we're switching gears just entirely. So my background in science actually is in chemistry. So I need to talk a little bit about that isn't just my background, it's chemistry, but we need to talk a little bit about material. And a lot of the stuff you guys already know, but it actually plugs into astronomy, to understanding astronomy. So you guys would probably tell me stuff is made up of atoms, okay? And the structure of an atom, these 3 pieces, when I say pieces, they're like the little particles that make up an atom. We have protons, we have neutrons, and we have electrons, okay? So actually I'm going to kind of hold you accountable a little bit to knowing that those 3 parts make up an atom. We need to talk a little bit about those. So the way this atom's drawn is, you kind of see that fuzzy sort of looking stuff? Okay, that's the electron or electron cloud. So the outside of an atom is the electron. And the reason it kind of looks buzzy like that is they're very fast and we don't really know where they are. So that's the electron cloud. And then the center of an atom is the nucleus. So that has the other 2 particles. So in the nucleus, you can kind of see these 2 colors. We have red and gray, okay? They represent the protons and the neutrons in the crunchy center of an atom. So protons are positively charged. I wish I had a little. So sometimes I'll put a little plus there by the protons. The electrons outside are negatively charged, and the neutrons, what charge are they? No charge. Neutrons, no charge. Yeah, they're neutrally charged. Exactly. Most atoms have the same number of protons in their center, which are positively charged, as electrons in the cloud. So if they have the same pluses and the same minuses, that makes them what we call neutral. Most of them are. Here's the deal. Okay, so in this room we have a table of elements. And you don't have to memorize this and all that.
The periodic table.
Periodic table, yep. So if you guys see that whole red number, like we have hydrogens 1, we go to heliums 2, lithiums 3, 4. That whole number there is the number of protons in an atom of that type of element. So hydrogens have 1 proton, heliums have 2 protons, lithiums have 3 protons, berylliums have 4 protons.
Generally, if they're balanced, they have the same number of electrons too.
What's that?
I said generally, if they're balanced, they have the same number of electrons.
Exactly. Yeah, if they're balanced, if the atom has no charge. So for instance, beryllium has 4 protons, and it usually will have 4 electrons. Yeah, exactly. So here's the deal, and I'll kind of tell you why this is important to astronomy. So stars, in the science of stars, and as stars live their lives and blow up, they actually are taking protons and squishing them together and making what we say heavier and heavier elements. So in our sun right now, it's the simplest sort of thing. We basically have hydrogen with 1 proton going to form helium with 2 protons. It's a conversion process. And in doing so, in the center of our sun, that's what we call fusion. And doing so, it liberates lots of energy. There's a little bit of mass lost, during that fusion process. And that mass is converted to energy. So as stars live their lives, and our star is pretty darn uncomplicated. Our star is pretty simple. As stars live their lives, they can actually go ahead and make heavier and heavier, more and more complicated atoms with more protons in their center. That's kind of what it is. So the number of protons, can you kind of see, like if somebody's like, oh, I have an atom here, I'm not sure what it is, but it has 16 protons in its nucleus. You're like, I know what kind of atom that is. I know that's a sulfur atom. So the number of protons we call the atomic number for the element, and it identifies the atomic number identifies what it is. Number of protons identifies what it is. Yep, and this is exactly what you said. The number of electrons are usually equal to the number of protons in the center. But does this make sense that if we have the nucleus with the protons and the neutrons, and we have the electrons buzzing around, actually, if anything can come and go, it's going to be electrons. So if we kick off, for instance, 1 electron, that means now we have 1 extra proton and electrons. That'll make a +1 charge on that new thing.
So you have a positively charged
cation. Positive charged cation. The other thing about electrons is sometimes and it's for different reasons, but sometimes it will pick up an extra electron. So now it has 1 extra electron, and then it has protons, and now it's negatively charged on the ion. But it's all about the electrons coming and going. Okay. So another thing, and I know we don't need to know much in this class, but another thing that's important about atoms is when you look at the nucleus, there's this important thing for a particular atom called its mass number. So literally you understand how many protons it has. Actually, this is how many protons it would have to have if it's sulfur. But the other thing in the center, what's the other thing in the center besides protons?
The neutrons.
Neutrons, yeah. You guys need to take my chemistry class. So, next question.
High school stuff.
Oh, come on. So, she said high school was enough. So, if you count protons, which would be 16 for sulfur, And let's just say it has 16 neutrons. 16 plus 16 is 32. So the mass number for that particular atom would be 32. So it's all about counting protons and neutrons. I kind of look at neutrons as kind of like the salt and pepper of the universe. So basically, something can have 16 protons, which makes it sulfur, which makes it sulfur, but it can kind of have an assortment of neutrons.
Neutrons really don't dictate the how you say it?
What the
Neutron,
element
yes,
is.
yeah.
Yeah, neutrons don't dictate what the element is.
Yeah.
It does dictate how much it weighs.
Yeah.
This actually I snagged from the internet. You can see the source. It's a really cool, if we just take a minute to absorb what it's saying. Well, first off, like where do you begin? When we start to talk about the formation of our, not just our solar system, but the formation of our universe. So we have planet, solar system, galaxy, Andromeda, Milky Way galaxy, Andromeda galaxy. Then we have clusters of galaxies, and those galaxies are all kind of arranged in the universe. But we can come back, we can use the observable data and come back to a time when our universe, when it first started, okay? And actually, as it first started, the only thing it had in it, the only types of atoms was hydrogen, helium, lithium, a dash of lithium, and a dash of beryllium, mostly hydrogen. So you're like, we have a lot of carbon in us. Of course, we have nitrogen, you've heard of magnesium, oxygen. All of that stuff came from stars. So we kind of have four options up here. We have elements that were formed as some stars merge, stars called neutron stars. We have, this is actually a nebula right here, this guy right here. And as they die, they make heavier and heavier elements. We have another type of star, two types of stars as they explode, either white dwarf explodes or massive star explodes. You can kind of see they're color coded. Okay, so I just think that's neat. Well, I think we'll start here. So Fridays are usually, we do something a little more interesting than just lecture, and we will, but there's a good chance Friday, just to kind of get down the road, that I will go ahead and finish up this part before, and then we'll do something different, okay? So Friday, I'm not sure, I think this room is available Friday. And so plan to be here Friday. If it's not available, look for the sign on the door. Okay? Any questions? All right.
Well, business law, it's bad this wasn't canceled today.
This one? What?
No, business law.
Is that video conferenced?